Okay, how to move heat, presented by Utah Mechanical Systems. The first topic of discussion is the refrigeration cycle. The refrigeration cycle is the process an air conditioner or heat pump uses to move heat from one place to another. It absorbs heat from inside the building, carries it through refrigerant, and releases that heat outside. This happens over and over in a loop using the compressor, condenser, expansion device, and evaporator. When you hear refrigeration cycle, think heat moving, not cold being created. Go ahead, Zach.
Yeah. So you have a refrigeration cycle. There's four main components. You have a compressor. You have an outdoor coil. You have a metering device. And an indoor coil. So the compressor is the pump. It's the heart of the system. It is pumping refrigerant in a loop. Like this.
So it goes from the compressor to the outdoor unit coil.
Yep. So the compressor takes your refrigerant and raises the pressure, right? It compresses it. So it raises the pressure and the temperature of the refrigerant. So this could be, we'll say 140 degrees, right? On a hot day, that might be 140 degree refrigerant. And what happens is it pumps it to this radiator with a fan. And this 140 degree refrigerant gets outside air blown across it. That's cooler than this 140 degrees. So this is 90 degrees blown across it, right? So this 90 degree air is going to absorb heat out of this 140 degree refrigerant. And then it's going to blow that heat outside. After it absorbs a bunch of heat, blows it all outside, this refrigerant has lost a lot of heat. So say it's 105 degrees now, right? We've rejected a lot of heat to outside. Now it's a liquid. It's 105 degrees, and it's coming in, and it hits this metering device. The metering device has a really small little orifice in it, which will drop the pressure and the temperature considerably, by about 2/3. So you'll come out of the metering device at around 40 degrees. This 40 degrees refrigerant is going to go to the indoor coil, which has a fan. And it's the same concept, right? Your house air, say this is 74, is going to blow across this, except it's opposite. Instead of rejecting the heat, we're going to absorb the heat. This is 40 degrees, and the air is warmer, so we're going to absorb the heat into this coil. And now, this refrigerant that comes out of it, that was 40, is going to come out at, say, 52. So it's absorbed 12 degrees, and it's going to go back to the compressor, and we're going to recycle it over and over and over again. We're going to reject heat, we're going to absorb heat. We're going to reject heat, we're going to absorb heat, until eventually your house is where you want it to be, whether that's 74, 72, 70. We can get it there. The lower you want it, the longer it takes, but the concept remains the same. This is all an air conditioner does. Heat pumps do the same thing, but the outdoor and indoor coil are flipped. This is the basics of it, the whole kit and caboodle.
And it's a closed loop, so
Yep.
you should never have to top up refrigerant
Yeah, there's nowhere for the refrigerant to go to leave the system.
unless there's a leak.
Right. If you need more refrigerant, the refrigerant has left and gone into the atmosphere. It does not get used or consumed. It does not wear out.
Vicky, what questions do you have about the refrigeration cycle?
Why does it get hot and then get cold? Why not just?
So pressure and temperature with refrigerant go hand in hand. You know how when you are using a lot of propane on your grill,
Compare it to an Instapot,
what?
like pressure.
Yeah. So you know when you're using a lot of propane on your grill, the propane bottle will get a bunch of frost around it, right?
Okay.
Because the pressure is going down on that propane. Temperature follows it.
Okay.
It's
Like
how
canned air, kind of.
like canned air. You blow off canned air, the pressure
Cold.
goes down and it gets cold.
Okay.
It's the same thing with this. The pressure goes up, then the temperature goes up with it. And then it's the opposite. This goes through a little orifice, the pressure goes down, and then the temperature goes with it.
So temperature and pressure are directly related.
But then it goes too much, and you have to heat it back up.
It's not getting heated back up, it's absorbing heat and
And getting heated back up.
yeah.
Yeah.
But
Because it got too cold.
No. You want
it's pulling house
so
heat.
you want it to get colder than your indoor air. That's how it absorbs heat. There needs to be a difference in temperature. right?
So if it came into the house at 74 degrees and the house was 74 degrees, it wouldn't absorb
It
any
it
heat.
wouldn't pick anything up, right?
pull
It's
anything
already
off.
the same temperature, yeah.
So if there's
So-
something wrong with the
So
system,
you
then
wanna
that would
drop
happen.
it down to around 40. You don't want to get too much colder than that because then you could start freezing up, right? If you get too close to freezing temperatures.
Mhm.
If you're at like 36 normally, and then your filter gets 30, then you're at 33, then you're at 32, then it turns into a block of ice and nothing's working, right? So this needs to be colder than your house air for this fan to blow across it. For it to absorb the heat, it needs to be colder than your house air.
Okay.
And then it goes back to the compressor, which raises the pressure and the temperature, which makes it hot again.
Why does it get hot again though? Why not just keep it at that 52 and then it's like colder? Because then it gets too cold and freezes.
So, if it's colder than the outdoor air, then the outdoor air can't absorb heat. So it needs to be hotter than outside in order to send the heat outside.
It's pulling the heat from your house and sending it outside. The heat energy.
Yeah. That's why you kick it way up to like 140, right? Because if it's 100 degrees outside, you need to cool this down with 100-degree air in order to reject the heat outside,
Okay.
right? I know it's a really weird
Yeah,
concept.
Yeah, my brain doesn't like that.
But-
The
It's
compressor
like making it hot to make
compresses
it
the heat energy.
Yeah, you are. You're making it hot to make it cold, essentially.
cold. Okay.
Okay, next concept. We will revisit that again after we digest that some.
Trust me, this takes a while to really grasp the concept of it, but it needs to be hotter than outside in order to reject the heat outside.
So
Because
that it doesn't get hotter. So that it gets colder.
so that it can get colder, right? So it's got to be hotter than outside in order to reject the heat outside.
Okay, you can leave that up for right now.
Oh, okay.
Next slide. How refrigerant works. And here's a hint. Freon is a brand name of refrigerant, and Freon is made by DuPont. Refrigerant
Okay,
can
you
move.
want me to explain how
I'm gonna-
refrigerant works?
I'm going to read this and then you'll elaborate. Refrigerant can move heat because it easily changes between a liquid and a vapor at normal system pressures. When it evaporates into a vapor, it absorbs heat. And when it condenses back into a liquid, it releases heat. The system controls where these changes happen using pressure. So heat is picked up inside the building and released outside. Refrigerant is not cold by itself. It is a heat carrier that moves heat from one place to another.
Yep.
And it's better than water because it's like chemically different than water. Because like water does the same thing in like a boiler system.
Yeah, it's more efficient.
It's more efficient because it's like chemically designed
It
that
can
way.
more easily absorb and reject heat than water. I mean, water's pretty efficient.
So it's kind of like how your blood cells can carry oxygen around.
Well, think about it like steam. A steam boiler is a good way to think about how it works. So there's a boiler, right? We'll think about it with heat, pumping heat into the house, right? You have a boiler, it's boiling, it makes steam.
Mm-hmm.
The steam flows throughout the whole house
Yeah.
into the radiators. The steam is hotter than the house air, so it rejects all that heat into the house. The radiators get hot, and then your house air absorbs the heat, and the steam will turn back into water, flow back down to the boiler, reboil, pick up more heat, go back to the house, and that's how a steam boiler will work. And flow.
Does steam ever come out of the boiler, or it's a closed loop again also?
The steam boilers are closed loops.
Okay.
I mean, like
They're supposed to be.
yeah,
as long as there's not a leak.
Right.
Okay, next concept.
So refrigerant works the same way steam and water works, right? Is you're boiling it off, and then you're condensing it down to a liquid, right? So you're boiling it, it's hot vapor, rejects its heat, and turns into a liquid. So steam is a very good analogy for how refrigerant works. It's the same concept.
Okay. So what is a SEER anyway? SEER stands for Seasonal Energy Efficiency Ratio. It is an efficiency rating for air conditioners, kind of like miles per gallon for a car. A high SEER means the system uses less electricity to cool the home, which usually means lower power bills. When you hear SEER, think energy use and electric bill, not how cold the air feels or how fast the home gets cold.
Yeah.
Can you explain a little bit about why or how there might be higher SEERs inside?
So SEERs are this process, these temperatures, this whole thing remains the same, whether you have a 13 SEER or a 23 SEER. The temperatures, everything remains about the same. It's the method in which you get there. Like these fans will be variable speed. So like on a cooler day, you can reject the same amount of heat outside by spinning the fan a little slower, right? The cold outside air will absorb heat better, so you have to move less of it. So you can spin the fan a little slower, save a little bit of energy. Same thing with the compressor. You can have a compressor spin high speed, slow speed, variable speed, and get the same amount of cooling capacity.
So if each component is slightly more efficient, it's controlled better, so it uses less energy to complete the same process.
Yes.
Okay.
And the system shuts off less. So most of the energy that is used in an air conditioning system is used during the startup of it. Right?
Turning it on.
Right when it turns on, that's when it uses all of the power, 10 times the power. It pulls tons of power in turning the system on and off.
Mm-hmm.
So a standard on-off system is going to be the least efficient.
Okay.
Which is like your 14 SEER. Just has a contactor, just bangs on, it's 100% or not.
Yeah.
The most efficient system will never turn off. It'll
on.
just back down and kind of idle.
Okay.
And so if you can remove the on-off cycle, you save energy, which is where all the variable speed and everything comes in, because that's what they're trying to do.
We're going to get into that next.
Is remove the on-off cycle. And if you can make a system maintain, we'll say 72, and it just idles at 15%, that's the most efficient an air conditioner can be. So that's the goal with the higher SEERs. But
So
the air is still just as cold.
So the lowest SEER is like the older stuff. It's 8 to 12 SEER. And then the standard efficiency stuff, like the most basic stuff you can get nowadays, the legal lower limit is 13 to 15 SEER, standard efficiency.
Yeah, it depends on the region that you're in.
Yeah, certain regions have
Farther
different...
north you go, you can get like lower efficiency equipment and get away with it.
Okay. And then the high efficiency stuff is considered 16 to 20 SEER. And then the 21 plus stuff is the highest efficiency that you can get.
Yeah.
What's the highest SEER you've seen? 27?
I think Dagan makes a 41.
Oh my goodness.
I don't know if it's on the market or not.
Okay,
But-
next concept. Next slide. Show me your AFUE. AFUE stands for Annual Fuel Utilization Efficiency. It is an efficiency rating for furnaces that shows how much of the fuel burned actually becomes usable heat in the home. A higher AFUE means less fuel is wasted and more is used for heating, which usually means lower gas bills. When you hear AFUE, think fuel efficiency and heating cost, not how hot the air feels.
Yep. So how hot the air feels is basically going to come down to the fuel type. Some of the hottest air that you can feel from a furnace is going to be oil furnaces, coal furnaces.
Is there a process like the refrigeration cycle but for heat? Like, could you draw that out?
It's way simpler. You take a fuel, you burn it, it gets hot.
And then you blow air over the heat exchanger, and that's how the hot air comes out of the vents.
Yeah. So the higher your AFUE, your AFUE, the higher that is, basically all it's saying is the lower the exhaust temperature, right? Because your exhaust, if your exhaust is 1,000 degrees, you're pumping all that heat out to the atmosphere, right? And not into the home. So furnace manufacturers have found ways to add more heat exchangers, secondary heat exchangers, all sorts of fancy fins and stuff.
On our screen we have a chart here that shows like motor speed, gas output, and their standard, mid-range, and high efficiency, and it tells you like the money.
So
and stuff.
they've found ways to get the exhaust temperature down as low as possible, so that you don't pump it outside. It's all being absorbed by your house air. So a 97% efficient furnace is going to have lukewarm exhaust temperatures, which is why they condense, right? Because they're lower than like the boiling point of water, so the water can condense out in the exhaust and drain out of the furnace. And that happens around 90% efficiency is when your exhaust temperature gets into the like 100 something degree range, which is why a 90% furnace is a condensing furnace, and then 80% is not a condensing furnace.
Explain the exhaust materials, like the metal or the PVC. That's not in our slides, so you'll have to explain why we do different PVC or metal exhaust types.
So that water that condenses out of exhaust is slightly acidic, and it will rot out a metal flue, which is why we need to use plastic and PVC on the high efficiency furnaces. Now there's exceptions to that, like stainless steel. There are boilers that use big double wall stainless steel exhaust pipes, and they're meant to condense. But if you put like a condensing furnace on an aluminum flue, that acidic condensate that's dripping out of the exhaust will just rot the whole flue away, like maybe within a year or two. Like, it's fast. It's not super acidic. It's not like harmful. It's about as acidic as a Coke. But imagine just pouring a Coke down there
metal
every day, right? It would rot it out. And so a high efficiency condensing furnace needs a PVC flue just so that it drains and the PVC won't rot out.
And a bad thing if you have someone do it incorrectly or put like a 90% furnace in where an old 80% furnace was without updating the flue material type is like it could rot through the metal flue, and then flue gases can come into the house and hurt you.
Yeah. If your flue rots out, your exhaust will just go into the home.
And is that CO2 or carbon monoxide?
Carbon monoxide, if you have an inefficiently burning furnace.
Okay. But otherwise
right?
it's just CO2.
CO2, heat, and water vapor are the three byproducts that you get from combustion.
Okay.
CO,
Carbon
which is
monoxide.
the dangerous one,
Yeah.
is from incomplete combustion.
Okay.
Right? And you can't smell it. It's colorless. It's tasteless. So you get carbon monoxide. Now there's normally always a little bit present because the furnaces aren't perfect. which is why you exhaust it to outside, right? But, I mean, ventless appliances exist because natural gas is fairly safe. And you can burn it in your house. As long as you have complete combustion, you only get CO2 out of it. The furnaces aren't perfect. They don't always get complete combustion, so you need to exhaust it.
Vicky, what questions do you have about efficiency for furnaces? Like as far as ordering parts or like understanding it when talking to customers?
How will I, so anything above a 90% efficiency, do I need to make sure we budget for new PVC flues?
Not if the old one is.
If you're switching from a metal flue to a PVC flue, we would have to charge extra money sometimes.
Yeah, we would have to do a whole new flue. If we're going from an 80% to a 90%.
There's extra labor. They have to run a whole new pipe out to the roof.
Right. If we're going just from a 90 to a 90, it's fine because there's already going to be a PVC flue there.
Hopefully.
There will be. There's no way that there was a 90% without a PVC flue installed.
I haven't seen one yet.
Right, I haven't seen one yet, but if somebody did do that, it's so egregious. 90% of furnaces have been around for decades. So like,
it's a really big mistake for someone to make to have
somebody
gone unnoticed.
The only way that would happen is if you were like following behind a DIY homeowner or a house flipper that doesn't know any better.
Yeah.
But like, I have never come across somebody hooking up a 90% furnace to a metal flue.
Okay, but if we're going more efficient, then I need to budget for a PVC flue.
Yeah,
Yep.
if we're going from an 80%er to a 90, then we need to budget to do a PVC
we have a price
flue.
for it in the price book. Like
And
a flat
another
rate.
thing is that you don't want to put a 90% furnace in an unconditioned space. So if you have a 90% furnace, and say it's pumping heat into an office,
Mm-hmm.
but that 90% furnace is in
A shed outside.
say a shed or an unconditioned storage area,
Or your garage.
or sometimes an attic space, that furnace can freeze. So there's all sorts of little drain tubes and pressure lines and stuff.
Oh, I remember we did a call like that once.
Yeah, and those furnaces will freeze.
Because they're dripping water all the time because they're condensing.
Correct.
And if the drains freeze, it'll make like a popsicle inside the pipe and back it up and clog the drain.
Yes.
And flood everything.
And then it shuts off on like pressure switch problems. So if somebody wants us to like, if somebody's like, yeah, I've got this, I have an office in my garage that I want to heat, we should recommend they use an 80% furnace.
Okay.
Because a 90% furnace in an unconditioned space can freeze, and I have seen that happen personally.
Okay, next concept. We're going to move on to what a ton is. A ton of heat. Tons refer to the size or capacity of an air conditioning system, not its weight. 1 ton equals the amount of cooling needed to cool 12,000 BTUs per hour, based on how much heat it takes to melt 1 ton of ice. A higher tonnage means the system can remove more heat, but bigger is not always better.
Yes.
It has to be matched correctly to the home. When you hear tons, think cooling capacity and system size, not efficiency.
More heat getting absorbed.
Why is it compared to melting ice? Because there's not ice, it's water or coolant.
So,
This is my favorite story. Back in the day,
back in the day, when before everybody had a refrigerator in their home and everybody needed large blocks of ice, we had to transport ice from northern lakes and stuff, and we had to store it. We had to ship it on trains. So initially, refrigeration systems were sized based on melting and freezing the ice that they were all based around, right? That everybody needed to buy ice.
because they created refrigeration systems to keep the ice colder for
The
longer.
very first refrigeration system was created for a print shop in Philadelphia to control the humidity. And then they realized
And
that
they
they
just
could use
never
it for other
updated that
stuff. It
for
was
what?
like 30 years later, they were like, we could put this in someone's house.
Make it colder.
Yeah, but
It was just stuck.
that's what it was invented for. That's the story. But
Yeah, it's all based off of blocks of ice that they use to transport, though.
Correct.
They're like, hey, in 24
And
hours,
it just stuck around a ton of cooling. It's
in 24 hours, this much ice melts in 24 hours, so that's a ton.
yeah. So we need this many BTUs, this many British thermal units.
That's what we're getting into next. What is a BTU? BTU stands for British Thermal Unit. It is a measurement of heat energy and tells us how much heat is being added or removed from a space. In HVAC, BTUs are used to describe heating and cooling capacity. For example, how much heat a furnace produces or how much heat an AC removes. When you hear BTU, think heat amount, not efficiency or speed. So can you dive a little deeper on, like, because I still don't understand the concept of, like, what is a BTU? What does it look like? What is it shaped like?
I could one sentence.
Tell me.
A BTU
Yeah.
is the amount of heat required to raise 1 pound of water by 1 degree.
Okay.
Okay?
So you need 1 BTU to do that?
You need 1 BTU to increase 1 pound of water by 1 degree.
Is there like a time limit?
Now,
Like
a pound of water sounds like a lot, but a gallon is like 9 pounds. So we're only talking about like a little cup of water here.
So is that like within 30 minutes or something?
There's no time. More BTUs will do it faster. But a BTU just refers to raising that pound of water by 1 degree.
So a candle, someone told me a candle is 1 BTU. Can you draw a BTU on the screen, on the board?
Well, the longer a candle burns, the more BTUs it will put in. There's not a time.
Okay, so if a candle is on for 1 second, that's 1 BTU. If it's on for 2 seconds, it's 2 BTUs.
Yes, if that's how big, if the flame is perfectly sized for that, yeah. But there's not a time
Okay.
for BTUs.
So
Just the amount of energy required to raise 1 pound of water by 1 degree. More BTUs will do that faster.
okay, so if I have 10 BTUs, that's the equivalent of having 10 flames on a candle underneath of that cup of water.
Because it'll do it faster than one.
It's more
Yes.
hotter.
That
Yep,
makes sense.
does it faster.
Okay, so it's not like 1 flame for longer is longer BTUs at the
Yes, 1 flame for longer is more BTUs.
over the time, but not initially. It's still just 1 BTU in the beginning.
It will just take longer, so it's less efficient.
Or does it get
Right.
more hotter over time?
Yeah, I guess. It's not as fast.
Yeah.
I don't know if it's more or less efficient, but a BTU...
Can you draw a BTU? What it looks
Yeah.
like?
It looks like this.
I knew you were gonna try. I knew it.
Okay, so it's like an energy. You can't see it?
Yeah, it's just a measurement of heat.
Okay, a measurement.
It's
Okay.
just a measurement.
Okay, next concept. Motor terms.
Oh, motor terms.
Motor terms. So this
Vicky,
is
we're diving deep. This is
to help Vicky and
like
Alicia.
a whole year of topics.
There's like
of
4
school that we're
Put
going
this with
over.
my
There's
screwdriver
5
here.
there's 6 terms. This is just to help her better understand so she can order equipment better. Okay, motor term. Single speed. The motor is either completely off or completely on or at one fixed speed. Is there anything else that we need to add to that? Single speed, where are these motors at? What is a blower motor and a condenser fan motor? Where are they at?
Oh, we were
I know
close
where
to
they are. I'm
that.
asking the question so that you can tell the
Okay.
class.
Remember my refrigeration circuit, and there was an outdoor coil right
Uh-huh.
here?
Yeah.
That would be the condenser fan motor.
That's a fan and there's a motor attached to it.
Yeah.
And it's either off or on. This goes into the
Yeah,
efficiency stuff we were talking
generally
about.
speaking, yeah, condenser fan motors, especially on like 14 seers,
This is single speed.
off or on.
Okay, and then the blower motor is inside the furnace.
Yep.
And you use it during air conditioning time and heating furnace
And
time.
heating. Yep.
Is that what we replaced the other day in that basement? That was short.
That was an inducer motor.
Which is a tinier
The
motor.
blower motor's the big one. That moves all the house air around,
Oh, okay.
right? So that pumps air through all the ducts. That's what blower motor, air comes out of the vents. Right? The one that me and you did is an inducer motor.
It's
It
littler.
does combustion air just for the fire, just for the little flames.
Oh, it just puts air.
It
so
just
fire
It
can
moves
burn.
air around inside the furnace.
Oh, okay.
It just moves that little bit of air through so that it can burn, yeah.
Okay.
So next is a 2-speed. Tell me what a 2-speed is. It's either how many speeds?
2.
Okay, so what are the options?
Low and high.
Or off?
Or off, yeah.
Okay. And tell me what multi-speed is.
I mean, 3 plus. You know, low, medium, high. Sometimes there's a medium low, a medium high, and a high. Right? A lot of the times. It's a multi-tap motor. The motor will have a bunch of wires coming out of it. They're color-coded. And you can change which speed tap the furnace uses based on the color of wire that you plug into the board.
And you can do that. So,
I
like,
can
if
do
a
that,
customer's
but it's
having
pretty-
problems, you can go and
Yeah,
change
like
stuff.
if there's like high pressure in the ductworks, right? Like if the ductwork is undersized and the blower's moving too much air, you can pull the high speed off and put medium high on.
And, like, cap it so it doesn't go too much.
Right, exactly.
Yeah. My thing says the motor has multiple preset speeds chosen by wiretaps, but only runs at one selected speed at a time. That's exactly what you said. Okay, variable speed. Motor can ramp up or down smoothly to many speeds automatically based on system demand. I explained this to customers like a dimmer switch, but someone told me once it like moves in percentages, like 1%, 1%, 1%, 1%. Is that correct? Or does it
I
have
guess
like...
it's whatever analogy you like better, because both of those are correct,
Okay.
right? I mean, like most of the time, those motors are going to have their top speed,
Okay. Maximum.
right? Which, like, they're going to be running at 60 hertz, their top speed, and then you can back it down from there. So yeah, the 1%, but it's a dimmer switch, right? Like a light bulb's only going to get so bright.
There's a
When
maximum.
it's all the way up, and then you can back it down.
And
then
this
run
is
slower.
the variable speed motors are inside of like those high efficiency units you were talking about.
Yeah. Most furnaces come with variable speed motors these days.
Okay.
Even the lower efficiency furnaces.
Because everyone's moving towards energy efficiency now. Okay, motor type. This is one where you're going to have to get into because I don't really know much. There's 2 types of motors. There's PSC motors,
Permanent split capacitor.
and then there's ECM motors.
Electronically controlled motors.
Okay. All I see here is one's older and one's newer. So what is like the actual difference?
The PSC is going to be your single speed, your multi-speed.
Okay, so
They have a capacitor on them
okay.
in the furnace.
Okay.
Right? That's the type of motor that we worked on the one night at the nice house.
With the cold and all that.
And also Denny's thing has that. Because there's a capacitor attached to it.
Yeah, his has a start and a run capacitor.
Okay.
So his is a PSC.
Yeah.
So
It has a
they're
capacitor.
still used.
They
even though
are,
it's
yeah.
older style.
Yep, it's an older style.
That's
They're
less efficient.
And then ECM motors, their computers have capacitors built into them, but it's not anything that we can change or test.
Is it like a little control board?
Mm-hmm.
So if that goes bad, the whole little control board has to get swapped out.
Change the whole control board out. Now, the way manufacturers do it is that control board, if you were to buy a replacement, you have to buy the replacement control board and get it programmed. And paying for all of that is almost as much as just replacing the motor and module.
Mm.
So you might as well just replace the motor and module because it's only going to be slightly more expensive, but you get a whole new warranty with all the new parts.
Yeah, but maybe we could still keep that motor
And it's the same amount of work.
in case we ever needed a motor. Like the motor's not bad, just
yeah,
the board.
I could hoard all of the good parts that we pull out.
Okay, next concept. Gas valve terms. We're going to go over single stage, 2-stage, and modulating. So what is single stage? What is a gas valve? Can you draw one? Like what it looks like or how it works or something?
Yeah, so you got a pipe coming in. Get your gas pipe.
Natural gas, right?
Natural gas, propane, right?
Mm-hmm.
And you got this thing, right? It's going to have a little thing on it. 2 wires, okay? And the 2 wires will send, say, 24 volts to this little box here,
Solenoid?
right? We'll open it up and let gas flow out.
Is it a solenoid?
Yeah, it is a solenoid.
Okay. What's the other wire?
What's the other? Common, a neutral. So
Okay.
there's 24 volts in
Mm-hmm.
and 24 volts out,
Okay.
which makes a circuit,
Okay.
right? And then this uses the circuit to energize the solenoid. The solenoid uses an electrical coil to create a magnetic force. The magnetic force opens the gas valve, lets gas flow.
How does it know when to open it?
The furnace tells it to turn on.
So you
So the
click
wires are connected to the furnace.
and the thermostat.
Yeah, the motherboard in the furnace.
And the thermostat, right?
The thermostat is connected to the motherboard in the furnace.
Okay, and then the motherboard's
But they don't
connected
directly talk to one another.
to. Okay, unless it's a communicating system. Or is that something else?
Sure. How complicated do you want this
We
lesson
are
to
going to
be?
go over communicating versus not communicating, but that's the last
Okay.
thing.
I just needed to know it knows how to turn on.
The
The furnace tells it to.
Furnace tells it to.
The furnace
Technically
gives that power,
speaking,
right?
The inducer motor turns on. The inducer motor will close a pressure switch. The furnace motherboard will see that circuit be completed, know that the pressure switch is closed. Then it turns the igniter on. Once the furnace motherboard sees the proper amp draw through the igniter, it will know that the igniter is hot, and then it turns this on,
Which will
and
help you
which
make
will
a
then
flame.
flow gas over the hot surface igniter
And that makes
and
a
make
flame.
a flame.
And then the heat
I
starts.
remember all of this.
Because I went to school for 5 years.
It's just in his brain, Vicky.
So-
I don't know.
It's a lot.
So the furnace motherboard knows when to turn the gas valve on. It sends 24 volts to the gas valve, it opens up, gas comes out.
And so when you have a no heat call, you check each one of those parts of that system in the order they're supposed to happen to see which part failed
Yeah.
of that
When I
sequence.
first get there, I see what error code the furnace has given me, and then I reset it, and I watch it run through that sequence of operations and make sure every one of those steps is working the way they need to.
Okay, so what is single stage? So that's your gas
So this
valve.
is a single stage.
Okay.
2 wires. You have power in, power out. Now, a 2-stage furnace,
That's
have a-
two-stage gas valve, right?
yes,
Okay.
we'll have a 3rd wire, right? Now the furnace will power one or the other,
So wait, single stage does what? It's either off or on?
off or on,
100% or
open
0%?
or closed.
Okay.
It's powered, it's not powered.
Okay, two
A
stage.
2-stage will have 3 wires, right? And a 2nd solenoid. Okay? Basically, it'll power one or the other. A low fire and a high fire. So it'll send power down one wire or the other and energize one solenoid or the other. And there'll be a little valve and a big valve.
So
So
you'll
you'll either
be-
get a little bit of flow or a lot of flow.
So you'll be 0%, which is off, and then like
50,
50%, and then
and then
100.
100.
Okay, so there's 2 levels of gas amount, which will make your flame bigger or hotter or whatever.
Correct.
Okay, modulating.
Modulating, you might have 5 wires.
Okay.
And you won't have a solenoid anymore. You'll probably have something called a stepper motor.
Oh, I don't know anything about that.
Yeah. So it's a motor. It's like a little motor, but it doesn't spin. It energizes it and it rotates in steps.
Oh,
And
so
it-
kind of like a.
Like 1% steps?
Like
castle door?
1/1000th of a percent steps.
Little-
So there'll be like
little chickas.
20,000 steps.
Little chickas.
Yeah, exactly. And as the motor turns, it can slowly open or close the gas valve.
Like a castle door.
Like a corkscrew, right?
Okay.
This stepper motor, it can say, okay, we need 18%. And so the stepper motor will move 600 steps, rotate that little corkscrew, which opens the valve up 18%.
Is this modulating or that's something else?
This is modulating.
Okay.
This is how modulating equipment's going to work.
Okay. And so
It's
it
basically the same for the metering devices, EEVs, all that
Same
modulating
concept.
valves and stuff. They all work the same way.
Okay.
Is this common?
Yes, it's all modulating equipment.
This
Whenever
is in
you
the
hear
high
like it's a
efficiency stuff.
modulating furnace, it's a 97% efficient furnace. It's communicating furnaces.
It's why they're more expensive because there's more
This
parts.
is the
and
kind
stuff.
of equipment that it has, is these gas valves. And then also in line with this is you get an inducer motor that works the same way. It's variable speed.
Variable
They can
speed.
ramp up and down by
Variable
percentages.
speed needs to have modulating.
Yeah, so you won't have a modulating gas valve. on
Modulating
something-
needs to have variable speed. Variable speed doesn't need modulating.
Yeah, right. You can have variable speed and
You can
have a
have a
single stage gas valve.
Right. You
But-
can have a variable speed
Blower.
inducer motor, blower motor, and all, and a single stage gas valve. Right. It's just kind of like overkill.
Modulating gas valve needs variable.
Yeah, a modulating
Yeah.
gas valve. I mean, unless you just bypass it all, because like you can operate this as a single stage,
Just take the wires off.
right?
But then you
Well,
paid all that money for a modulating
Right.
system
Then
and
you
you're
paid all that
disabling
money,
it.
and it's still going to work the same. It's still going to use a stepper motor, but it would just open 100% or 0%. And so it's still a modulating gas valve. You're just not using it as one.
Some people will do that, like hack the system if they can't like figure out what's wrong with it, or like it got installed incorrectly, or
Well, sometimes guys, you'll come across a furnace, guys will just have all this cut out. They use a little relay, and then instead of like communicating with this gas valve, they just use the relay to send 24 volts to it and just max it out.
and it's never turned off anymore after that. It's just on.
No, that's what the relay is for.
Oh, it can go off and
it's
on.
off and on. You have eliminated.
They do that if they're having problems troubleshooting like the modulating part
Yeah,
of it.
they'll just or if they only have a standard gas valve on the truck, right? And a lot of companies that only use truck stock, they won't pay a tech,
to drive.
especially a commissioned technician. They won't pay that tech to go out and get a modulating gas valve. They'll just hack this whole system up to put a single stage Honeywell into this $2,000 furnace.
So as the customer, it's important to know that, like, if your repair is gonna affect your modulating functions, or like if you know that you have high efficiency equipment, if any of that stuff's getting disabled or tampered with.
From a customer's standpoint, they'll probably never know, because like the furnace will work, and they'll have heat again.
But I read that modulating stuff feels more comfortable and like
Yeah, it does. That's why we put it in our house, because it's quieter,
yeah.
right?
So you don't want someone to come and do that basically.
No, you don't. This is not the right way
So
to do it.
if-
But it happens.
If we're replacing a furnace that is modulating, I need to make sure that the air conditioner they have is variable.
No.
The blower in the furnace is variable. If you get one with a
Oh.
modulating gas valve inside of it, it will come with a variable speed motor.
Okay, so that's not something I need to.
We're gonna go into
We're
the
A furnace and a regular AC unit.
yeah. You
Okay,
can.
so the valve goes with the.
Okay, next slide. AC and heat pump terms. Air conditioning or heat pump cooling compressor operation. So these terms are in reference to the compressor inside of the outdoor unit in the AC. We have single stage, two stage, and variable capacity. So same concept, different function. Can you just explain a little bit about how it works with like a compressor? Is this something you can like draw the compressor?
Yeah.
Sweet.
There's a few different ways compressors do it. This gets a little complicated.
All right. This is a treat.
You can have a 2-speed.
Is that two stage,
Yep. You'll have a low and a high speed compressor.
or is that the fan, the speeds?
This is the compressor.
Okay, got it.
We're just talking about the compressor.
So speed is
Everything
same
I'm
as
going to
stage.
say is in reference to
The compressor.
compressor.
So speed is the same as stage.
Yeah, because the faster this goes, the more refrigerant it's moving. Right? So the more BTUs you can move.
Okay.
You're going to be able to absorb and reject BTUs faster if you're pumping more refrigerant.
Okay.
That's the concept behind multi-speed compressors.
Okay.
All right. Now you can have 2-speed. You can also have variable compression. Right. So this is still going to be a 2-stage furnace.
No, AC.
Yeah, AC unit. So this is where your power comes in, right?
Yep.
And you power this thing up, and it pumps. It pumps the refrigerant, and the refrigerant comes out right here, right?
Okay.
So you'll have your power coming in, and this is where the refrigerant comes out. Now the refrigerant goes around and around and around in this little thing. It's called a scroll, and then it comes out high pressure.
This is a scroll compressor.
Now, if you want to have a low speed on the single speed compressor, if you want to have like a low stage cooling, reduced capacity, they'll have another set of wires that come in over here. Okay?
Okay.
And this energizes a solenoid, and that's referred to as an unloader.
Okay.
And what it does is they'll energize this, right? Which means that the refrigerant that goes around and around and around up here only does it about half as much. And then it gives it an easier path out. So it's only compressing about half as much when this solenoid is open.
Okay.
So it's still spinning the same speed. The refrigerant's just taking a shorter path. Does that make sense?
Yeah.
So that it pumps half as much and you get a low speed. Now the compressor is spinning the same speed, but it's doing less work. So it uses less energy.
So it's higher efficiency.
So it's higher efficiency.
Okay.
Does that make sense? This is clear as mud?
Sort of, yeah. I don't really understand it. So I get that there's single stage, 2-stage, and variable capacity.
Okay, so that would be a 2-stage.
That
Low
one's
and
a
a high.
That one's a 2-stage. Okay, low and a high.
That's a 2-stage.
So it's either off, low, or high.
Off, low, or high. It's got a solenoid in it. The solenoid is like an unloader. It unloads the compressor.
Okay.
So it pumps less.
Okay.
And then variable speed, just like a variable speed fan, the compressor can ramp up and down. Your outdoor unit's going to have a big inverter board, and it can ramp up and down, and that's all it's going to be.
Okay. Are you gonna do variable now?
That was variable.
Okay, pause.
So think about this. There's a piston.
Okay, this is a scroll compressor,
Right, there's a piston.
like in an engine, right?
Just like in an engine. And they're in cylinders.
Just like in a car engine.
Just like in an engine.
And it moves up and
And
down.
they come down here. There's this. And they go up and down, up and down, up and down through valves. And they're pumping.
And inside of them cylinders is
compressing.
refrigerant.
Is refrigerant.
And every time it moves, it pushes it and
It pumps,
squishes
and
it.
there's valve springs, right? And so it goes down. And this valve can only flex down.
So it sucks
So it
refrigerant.
Sucks refrigerant in.
Okay.
And then the valve closes, and then the piston goes up, and the valve's closed, and then this valve can only go up. So it pumps it out, and then it comes out high pressure, right? Because the high pressure forces this valve open.
Okay. And so
And that's it.
a single stage does that once. And a 2-stage can do it twice. There's 2 levels of it.
So new compressors have these things called scroll plates in the top of them. There's a stationary one, and there's an oscillating one.
Was the one you just showed me with the pistons was not a scroll compressor?
That's a reciprocating.
Okay, that was the old kind.
That's the old kind.
This is the new kind, the scroll compressor.
There's a scroll compressor.
Okay.
Okay? There's
it.
a stationary scroll and an oscillating scroll. And they mesh together. The 2 scrolls mesh together. Now, if you're looking from the top down onto them, the scroll plate looks like this, right? The refrigerant comes in right here, okay?
Uh-huh.
And it goes around.
Is it like a coil, like
It
a
goes
loop, like a
around,
garden
and
hose
It goes
loop?
around. It goes like that.
Like a pipe in a
and then
spiral?
it comes out right here in the middle. Comes out the top and away.
Okay.
And there's two of these. They're shaped exactly like this, and one of them oscillates in a circle. And it
like
pumps.
the actual thing will move, physically move.
One of them will. There's two of them. There's two of these. They look just like this. They're spiral.
How can they move if there's copper pipes attached
One of
to them?
them's fixed. The copper pipe is mounted to the outside of the compressor.
Okay, so it's just like liquid.
This is inside the compressor.
Okay.
The
Got
whole compressor is full of refrigerant.
Okay.
Okay, there's two of these plates. They're spiral shaped.
Oh, it's a really tight spiral.
Yeah.
I think I've seen them.
The two plates are meshed together, and one of them will oscillate like this.
Oh, so when the outside
So,
of the spiral moves, it like
when
wiggles
when it moves, and there's two of these spirals meshed together,
Mm-hmm.
this space in between the two spirals
It gets smaller.
will create a gap and pump the refrigerant in a circle.
And then it gets smaller.
And then it
'cause it's
comes out
wiggling.
through the center, up and out,
Okay.
when it reaches the end.
And that movement creates the pressure.
Correct.
Okay.
It's the same concept as the reciprocating one, though.
Yeah, just a
How
different
it
shape.
pumps up and down.
Yeah, this one just wiggles. This one just
This one
wiggles
just goes
left
in a
and right.
circle. Right, basically.
Okay.
Yeah. And so,
These are louder than the old kind?
no. These are
Quieter.
way quieter.
Okay.
Yeah. So, these compressors will unload. And instead of it coming out through the center, right? So, the maximum amount that it can pump is going to be full speed, sucking in gas, pumping it out through the center. You'll have something like a gate, like right here. So it'll pump it halfway, and then it comes up and out.
All right, we're up. Okay. So what does all of it mean anyway? More stages or variable speed usually means better comfort, quieter operation, and higher efficiency. Single stage and single speed systems are cheaper but louder and less comfortable. Can you explain why it's less comfortable? Like, what does the customer actually experience?
All right. From a customer standpoint, so think about a low efficiency system. It's going to operate like this. So we'll say this is temperature. So this is time. This is temp.
Okay.
This is what your house is doing. And you're going to have a thermostat controlling this, just like a regular single stage thermostat.
Let's say I set it to 70.
Yep, 70, right? So 70 is right here. And the system's either off or on, right? So your thermostat is right at 70. That's our baseline. And we come up 71, we'll
This
say
is
71 and a
in
half.
summertime. It's getting hotter in the house.
Yeah. Yep. And so then your AC kicks on and it cools it off. And then it shuts off.
It cools
It
it down
waits.
to like 69.
Your house heats up and then the AC kicks back on again. It cools it off, shuts off, and it waits. Cools it off again, right? And your temperature in your house is going to do this all day long. That's how a 14 SEER unit is going to maintain your temperature.
So the temperature is always going up to 71 or 72 and then down to 69.
Right.
It's always going
on
up and
off.
down, up and down.
It's on or off. 100%, 0%. Now, you can get a 2-stage, right? And it'll do the same thing, except the 2-stage will kick into low, and it'll kind of spread out these peaks and valleys a little bit. Because it's going to shut on and off less.
Okay.
Because it's going to go into a low speed and kind of maintain this temperature
Better.
longer, better, right? So, but you'll still have the same peaks and valleys. They'll just be more spread out
Okay.
with a 2-stage.
So less noticeable for the customer. They're not like, oh my gosh, it's hot in here now. Oh my gosh, it's cold now. Oh, now I'm
Right,
hot.
you won't notice it as much.
Okay.
But that's how you get more efficiency, because you're turning it on and off less. Now, a variable, like a communicating variable speed furnace,
Mm-hmm.
say it's you set it for 70 and your house warms up at 71, it kicks on, it starts cooling off, the furnace will see it start cooling off. It's got sensors that can detect the return air temperature coming into the furnace, not just the thermostat, but what the furnace is actually experiencing itself. And so it'll ramp down, and it'll kind of find like an equilibrium and just kind of idle.
So does the furnace turn the heat on?
Yes.
So it won't let it go down to 69. It's like, nope, stay at 70.
It's not going to turn the heat on in cooling.
Okay.
It's going to ramp the cooling down.
Okay.
A really high efficiency unit is going to ramp the cooling down.
Oh, so in summertime it's
So
not going to
will-
use heat.
It will never turn on and off. The system will just run all the time at, 10-15% and maintain this temperature perfectly. Instead of having these on-off cycles, the AC unit will back way down. It'll spin real slow. It'll spin the fans real slow, but it'll always be cooling the whole time. And it'll figure out how to cool to maintain that 70 degrees without overcooling the space.
Okay.
But a lower efficiency AC unit, like a 14-seer, doesn't know how to do that. It's just 100%.
Okay.
So it can't do this. It'll just 100% drop the temperature in the house and then shut off. But a variable speed communicating system will see that it's getting close to this temperature and then back down. And the thing is, if this temperature, if you're set at 70 and you hit 70.2, then it will ramp up a few more percent and then maintain this at 70. Right? It'll see like, oh, we're at 70.2 degrees now. Let's ramp up. Let's go from 12% to 20%. And then it'll bring this temperature back down to 70 and keep it right at 70, right where you want it.
Okay, there's only 2 more things left. Last thing is, we're just going to talk about airflow directional furnaces, upflow, downflow, and horizontal. Can you just explain the difference between those?
Yeah. This is a house.
That's my house.
Okay.
It's beautiful.
Yes. So, there's a few different ways you can do these. Let's start with a downflow. If this house is sitting on a crawl space, like this, right? You got a little crawl space here under the house. You can put the furnace in a closet right here, right? It'll blow down.
The air blows down.
All of your ductwork will be in the crawl space like this. And then you'll have vents in the floor like this.
Or the bottom part of the wall.
Yeah, or the wall.
But they'll be near the bottom.
Same concept. This will blow down, but it's other ductwork. Sometimes you'll find it cheap and it'll just be like a vent in a wall right here. Right? And the air filter just like that. And this is sucking in air.
That's your return.
Sometimes they go up into the attic with it, and then you get a return in the ceiling, right? But this is going to blow down, and all your vents will be down by the floor. That's a downflow furnace, right?
That's
You
how
see it a
we'll
lot with
remodel.
And
crawl space
the
houses.
coil for the AC will be underneath the furnace.
Yeah, if there's an AC coil, it'll be right there. The furnace will be sitting on it. So that's a downflow furnace. So then you can have an upflow furnace, which
Put it in the basement. Here's the basement.
now you have a real basement, okay? And you put a furnace down there, okay? You'll have a duct coming down to the furnace like this,
That's the return.
okay? Yeah, and say it comes up to like some vents upstairs, and the air comes down to the bottom of the furnace, and then it goes up. Furnace will pump the air back up another duct, right, which will go out, and you'll get vents in the floor again. You can also put this on the first floor, right, and it'll pump up.
But then it doesn't heat your basement?
Yeah. And
Some houses have two systems. They'll have one in the basement and one on the first floor.
or one in the attic, but you'll have vents up here, and it'll blow down. But upflow furnace is going to sit on the ground. Your ductwork is going to come down to it. It's going to blow air up, and then you'll have vents, right? If you have a basement, you'll probably have some vents in the basement as well.
If not, we can cut vents in. Sometimes.
And then, last but not least, is going to be a horizontal, which is my favorite. And they're in attics. We were working on one of these the other day.
Sometimes they're in crawl spaces too. Horizontals.
Yeah.
They're in usually tight spaces.
So, you'll have your return. That'll come across. You'll have your filter right here. And then you'll have your supply duct, which will come down. You'll have vents all over. But this will be a furnace on its side, and it's pumping air like that. That's a horizontal. And sometimes you'll see a horizontal in a crawl space. Generally speaking, if you come across a horizontal furnace, it's a bad time. It's not going to be fun.
Yeah.
Because they'll be in crawl spaces or attics.
Okay, so
And then you can have a multi-positional furnace, which typically can be a horizontal or an upflow. The downflows generally are built to be downflows because everything is reversed, and they'll be built to be a downflow. And if you get a multi-position, it's either a horizontal or an upflow.
So when you're ordering furnaces, Vicky, you can either order a downflow or one that can do upflow / horizontal.
Yeah.
It'll say it on the website, upflow / horizontal. Last topic, and then we'll end the training. Most of this was to help us understand what the different terms mean when ordering parts for training. But I think it's really educational for homeowners. So I'm going to read something short about how a homeowner can make a decision on, like, it's really overwhelming. How can they choose what system is best for their house? And then I'll open it up for you to give your opinion on it. Basically, when choosing a new HVAC system, homeowners should think about how long they plan to live in the home. Higher efficiency, variable speed, and communicating systems usually cost more up front, but they save money over time through lower utility bills and better comfort. If someone plans to stay long term, those upgrades often make sense. If they plan to move in a few years, a solid mid-level system can be the smarter financial choice. Do you have any other input on, like, how a homeowner can navigate this decision when they're presented with 3 different options of, like, low efficiency, high efficiency?
And it's not always just about efficiency. It's going to come down to their budget. Higher efficiency systems are typically quieter.
Mm-hmm.
They can better maintain the space temperature.
What about maintenance costs?
So really marginal. The only thing is that the more expensive, higher end equipment costs a lot more if it does break.
So, like, if a motor goes out and it's a variable speed motor.
Yeah, you could be talking about a difference between $100 and $1,000.
Yeah, like $100 motor, which would end up being like a $3
or an $80 gas valve and an $800 gas, or a $1,400 gas valve, or more.
Yeah, and that's
Right,
not even
for, like,
labor to
some of
have
those-
someone come do it.
Right, for some of those modulating things, they're extremely expensive to fix. But that equipment, it operates quieter, it maintains a better comfort level, it's smarter. You can integrate humidifiers and other accessories into that stuff more easily.
Mm-hmm.
So really, it's just going to come down to the budget and what the customers are going to get. If they want something that's super quiet and they never notice it's running, They
Like
should
if-
get that. Whether
if-
they're going to be there for 6 years or 16 years.
Like if the unit's right underneath like their child's bedroom or something.
Yeah. Or if the AC unit is right outside of a bedroom window and you hear it turning on and off and it's loud and it gets on your nerves, maybe the efficiency is secondary, but if you buy a more energy efficient unit, you'll never hear that unit running, because the higher efficiency units come with sound blankets. They come with more efficient, quieter fan blades, and they operate slower, and you'll never hear it running.
Okay, so last question, and then we'll end the training. How can a customer decide if they should get a regular traditional style system or like a dual fuel heat pump setup?
Yeah, so a customer can decide on whether or not to get a heat pump based on their individual needs. Especially if they don't have natural gas coming to their house. If a customer has electric heat, a heat pump's going to be a lot more efficient. If a customer has a propane tank in their yard and they have to get propane deliveries, a heat pump can make that propane stretch a lot longer between deliveries. So in situations like that, I think it's really smart. If you live down in the valley, a heat pump will be more efficient. It's better for the air quality in the valley to burn less fuel if you can get away with a heat pump. They're not perfect. They don't last all winter. When it gets extremely cold out, you're still going to want that warmth from a furnace, in my opinion. But yeah, they help stretch your propane for sure if you don't have natural gas.
And solar panels?
Yeah, solar panels. If you have solar, think a heat pump's going to be heating your house with electricity
Instead of gas.
And so it can be cheaper, especially if you're generating your own solar and you have the batteries to support a heat pump. Yeah.
Okay, sweet. Thank you, Zach.
You're welcome.